So we were discussing sheet metal operations. We will continue that. Here it is. I think I am not sharing. So is the screen visible?
Yes, sir.
Yes, sir.
We were discussing how to reduce the cutting forces. So there are different ways. This is what is called as the providing shear. So shear can be provided on the punch. It can be provided on the die also. This is what center of pressure. Die design we won't be able to do it. Then strip layout also we saw how you have to check for the different permutation and combination, and you have to see that strip utilization is more. Then we also saw strippers, how to hold the punches. These are the different pilots. One is your direct pilot and another is your indirect pilot. So this was direct pilot, which is hold with the help of a screw. Then pressure pad. Pressure pad is used while drawing operation is performed, and this is what your drawing operation is, in which your blank is hold with the help of the blank holder. And this is the punch which goes down, and the clearance is such that your material flows in die and punch. So if the strip thickness is 1 mm, the minimum clearance should be 1 mm or little more than 1. So how to calculate the blank size? How to calculate the blank size? So this is a cup. This is a cup, and this cup is made from this blank. The outside diameter of the cup is D, and the height of the cup is H. So how to calculate this D? So capital D is equal to under root of d square plus 4dh. Remember, here this d is outside diameter and h is from here to the end. So many times they give inside diameter and inside height, and they also mention the thickness. So in that case, you need to add the thickness accordingly. Now this formula is applicable if d by r ratio is more than or equal to 20. And what is your radius r? R is the radius of the bottom corner, that is this radius. So if first you have to calculate the d by r ratio, and if d by r ratio is more than or equal to 20, then you have to use this formula. If d by r ratio is between 15 and 20, then this is the relation. If d by r is less than 15, it is not between 10 and 15. If it is less than 15, then the formula is this. So these are the formulas for calculating the blank size. Then number of draws, that is, like suppose if you have diameter, blank diameter as say 200 millimeter, and if you want to make a cup size of say 20 mm, then you cannot do it in single draw. So for that you have to decide how many draws will be required, 1, 2, 3 or 4. So that depends upon the ratio, height to diameter ratio. So this is your height and this is your diameter. So if height to diameter ratio is more than 3.5, height to diameter ratio is more than 3.5, that means what? It is very deep. That is called the deep drawing. When height to, like suppose if the diameter is say 20, then for 3.5 ratio, or let us take 5, 5 ratio, this height will be 20 into 5, so 100 mm. So imagine a cup of 20 mm dia and 100 mm deep. So that is what is called as the deep drawing. That is called the deep drawing. So the number of draws will be 4 in that case. Number of draws will be 4. So if the ratio is up to 0.7, 1 draw. 0.7 to 1.5, 2. Like that it is 3 and 4. Now what is drawing force? So the force required to draw a shell. What is the force required to draw? That is what is called as the drawing force, and that is given by this relation, pi dt sigma y. So d is the finished shell diameter, t is the thickness, then this is your sigma y, that is yield strength, tensile strength. Capital D is the blank diameter, and this is a constant, which is between 0.6 and 0.7. So one is your drawing force, then another is your blank holding force. So you have to hold a blank also, isn't it? So that force is also required, right? So that force is also required. Like I told you, typical mechanical press for blanking and piercing. So for that, you have to calculate the blanking force as well as you have to calculate the piercing force. You have to add it, and you have to also add stripping force, and you have to come, or you have to calculate the tonnage add करके. So similarly here for drawing press, you have to add drawing force and you have to add blank holding force. So blank holding force is generally 1/3 of the drawing force. Like suppose if the drawing force is say 300 kg, then blank holding force is 100. So 300 plus 100, so 400 kg. So आधा टन का hydraulic press, 400 kg, 1000 kg is 1 ton, 400 is approximately half ton. So you will need a hydraulic press of half ton. Okay, so that was your drawing. Then you have bending die. Now this is bend. This is the side view. Now again for bending also you need to calculate the develop size. Develop size. मतलब before you start bending, you need to have a blank. You need to have a blank. You need to have a blank. So what is that blank size? So this is the terminology. So you have this angle, this bend angle, then this is the tangent point from which the radius is starting. This is again a tangent point from which the radius is starting. Okay. So from this point to this tangent point, this is for the setback, and this is your setback. So if you look at this layer, bottom layer is under compression और उसका जो लेंथ है वो कम होता है, and this top layer that is under tension, उसका लेयर है वो बढ़ता है, उसका जो लेंथ है वो बढ़ता है टॉप लेयर का लेंथ along the neutral axis it remains the same, it doesn't change. बाहर का लेंथ है वो बढ़ जाता है और अंदर का लेंथ है वो कम होता है. So how to calculate the bending length or develop length? So you need to know the bend radius, that is this is the bend radius inside. Then calculate the bend allowance. So bend allowance is calculated by this relation, that is B is equal to alpha, V is equal to alpha into R plus K. So alpha is nothing but the bend angle, R is nothing but the inside radius, and K is the distance of neutral axis from inside surface of the bend. Then how to calculate the bending force? So this is the formula for calculating the bending force. So for V bending, it is given by this relation. F is equal to this K into I into sigma ut into T square upon W. So here this is not I, this is L. L is nothing but the length of the bend, ultimate tensile strength, blank thickness, that is this T. K is die opening factor, and that is, or it varies from 1.2 to 1.33. And for U bending, you have to take K as 0.67. W is the width of the die opening. W is the width of the die opening. That is this W. So how to calculate this W? That is given by R1 plus R2 plus C. And what is R1? R1 is punch edge radius and R2 is die edge radius, and C is the clearance. What is punch edge radius? I will show you here. Punch edge radius like this. This is your punch. So punch edge radius matlab this. This is your punch edge radius. Drawing is also kind of bending only. And die end radius matlab this. RD. See, here it is shown. RD is nothing but the die end radius, and this RP is nothing but the punch end radius. Punch end radius. So it is very simple, not calculated. not at all complex. Now spring back, everything is important. स्प्रिंग बैक मतलब क्या, लाइक सपोज आपने बेंड किया, तो बेंड करने के बाद वो वापस ओपन होता है थोड़ा सा, तो दैट इज व्हाट इज कॉल्ड एज द spring back. And generally the spring back occurs when it is in the elastic condition, elastic state. So how to reduce this spring back or how to eliminate the spring back? So one easy method is based on the experience. Like अपने को मालूम है कि हम लोग बेंड किया और वापस वो खुलने वाला है, तो वी नो सपोज वो 2 डिग्री वापस खुल रहा है ऑन एक्सपीरियंस, तो हम लोग क्या करेंगे, बेंड है वो 2 डिग्री ज्यादा बेंड करेंगे, so you get a proper one. So that is one method to reduce the spring back, and that is called as the overbending. These are the techniques to prevent the spring back. So this is overbending, मतलब ज़्यादा बेंड करो. Second is bottoming, third is stretch forming, and fourth is ironing. So only these two are popular, overbending and bottoming. तो overbending में हम लोग थोड़ा सा ज़्यादा बेंड करते हैं, that is, हाँ, फिर वो डिजायर्ड एंगल में आ जाता है. हाँ, वंस बॉटमिंग में क्या करते हैं हम लोग, वर्क पीस इज सब्जेक्टेड टू हाई कंप्रेसिव स्ट्रेसेस. सो बॉटमिंग का फिगर यहाँ पे है ही नहीं, बट उसमें से एक पिन रहता है, जो पिन है वो उसको, ये जो बॉटम है उसको पकड़ के रखता है. दैट इज व्हाट इज कॉल्ड द बॉटमिंग, एंड दैट्स व्हाई इट डेवलप्स हाई लोकलाइज कॉम्प्रेसिव स्ट्रेसेस. देन स्ट्रेच फॉर्मिंग, स्ट्रेच फॉर्मिंग में मेटल इज बेंड बियॉन्ड द इलास्टिक लिमिट, मतलब डायरेक्टली वो प्लास्टिक स्टेज में जाता है, तो इट डजंट कम्स टू इनिशियल स्टेज. एंड देन आयरनिंग, आयरनिंग मतलब जो हम लोग इस्त्री बोलते हैं ना, प्रेस. सो फॉर आयरनिंग वी नीड टू यूज द वाइपिंग डाइज. ये ऐसा, दिस इज फॉर द वाइपिंग डाइज. ये दिस लुक्स लाइक अ वाइपर. सो दिस इज आयरनिंग. सो हम लोग जैसे कि आयरन करते हैं, सो दैट the wrinkles are removed and again the wrinkles are not generated. So these are the four methods to overcome the spring back. Now here are some examples. I will just take some few, like you have to find out the tonnage. So here it is mentioned, find the total pressure, dimension of the tools to produce a washer of 5.5 centimeter outside diameter, 2.5 centimeter dia hole from a material of 4 mm thickness having shear strength this. So outside diameter 55 millimeter है. First we are converting into millimeter. Why? Because the shear strength is given in 350 Newton per millimeter square. Alright, so we'll convert everything into millimeter. So all the dimensions जो centimeter वाला है, that has been converted into millimeter first. So you got 5.5 centimeter as 55, 2.5 centimeter as 25 millimeter. Thickness is already in millimeter, and shear strength is 250 न्यूटन पर मिलीमीटर स्क्वायर. ओके, सो नाउ फर्स्ट विल वॉशर है, तो वॉशर में क्या रहेगा, ब्लैंकिंग एंड पियर्सिंग. सो फर्स्ट नाउ विल कैलकुलेट द ब्लैंकिंग फोर्स. तो ब्लैंकिंग फोर्स के लिए obviously you will consider the outside diameter. And what is the sheared area? Sheared area will be pi d into t. Pi d into t. That will be sheared area into the shear strain. Remember, when you are calculating the blanking force, that time you have to consider the outside diameter, blank diameter. Okay. So pi into blank diameter is how much? 55 into thickness. Then piercing के लिए अंदर का डायमीटर, इनसाइड डायमीटर, so पाई डी टी, तो पाई इंटू 25 इंटू 4 इंटू 350. और फिर हम लोग टोटल अभी ऐड करने का. ठीक है, सो 351 पॉइंट, ये आपका न्यूटन में आ जाएगा दिस. ओके, सो इफ यू वांट टू कन्वर्ट इट इनटू टन्स, सो फर्स्ट यू कन्वर्ट इट इनटू केजी. सो 351.857 इंटू 10⁻³ न्यूटन है. सो केजी के लिए यू डिवाइड बाय 10 अप्रोक्सीमेटली, and then you further divide it by 1000 to get it into tons. So that means इसको आप किलो न्यूटन को 10 से डिवाइड करो, और ये जो है न्यूटन, इसको 10⁴ से डिवाइड करो, सो 35 टन्स. नाउ हाउ टू कैलकुलेट द टूल डायमेंशन. टूल डायमेंशन मतलब क्या, ब्लैंक डायमीटर, ब्लैंकिंग का डाई डायमीटर और ब्लैंकिंग का पंच डायमीटर. सिमिलरली पियर्सिंग का पंच डायमीटर और पियर्सिंग का डाई डायमीटर. नाउ हियर यू हैव टू रिमेंबर, इफ इट इज अ ब्लैंकिंग, if it is a blanking operation, very very important, then blanking का जो die है, that size has to be same as the desired size. Like desired size मेरा कितना 55, तो मैं blanking का die size will be 55. Okay, so the clearances in case of blanking is provided on the punch. मतलब पंच का जो डायमीटर है वो कम करते हैं हम लोग. हाउ मच? नाउ क्लियरेंस कितना है, 5%. So total per side, so total will be 10%. So 55 minus 10% of the thickness. Thickness is 0.4. So 55 minus 0.4. So this is the blanking punch diameter. Now in case of piercing, so piercing का पंच साइज है. ओके, सो ये अभी आपका ब्लैंकिंग पंच हो गया, ब्लैंकिंग डाई हो गया. ठीक है, अभी पियर्सिंग में कैसा रहता है, पंच का जो साइज है दैट विल बी सेम एज द होल साइज. अभी होल साइज कितना अपना 25 मिलीमीटर, बराबर है. तो पियर्सिंग का पंच साइज विल बी 25. एंड व्हाट विल बी द पियर्सिंग का डाई साइज. सी एवरीवेयर यू नीड अ डाई एंड पंच, एनी ऑपरेशन, शीट मेटल ऑपरेशन, डाई और पंच. तो ब्लैंकिंग का डाई हो गया और ब्लैंकिंग का पंच हो गया. अभी पियर्सिंग का पंच, piercing का punch size will be same as the desired size of the hole. Piercing मतलब making a hole. और piercing का जो डाई रहेगा उसका साइज क्या रहेगा, you have to add in the die. So piercing die size will be 10% of the thickness, 5% per side, so 0.4. So what will be the piercing die size, 25.4. Okay, so this will cost you 5 marks ये पूरा. ठीक है, so that was your sheet metal operation. Then I have shown this. So again, this is a kind of a revision. So this is your punch, this is your die. These are the various operations. This is cutting off. This is again cutting off. In cutting off straight, cutting off incline, cutting off along radius. This is notching. ये notching है. ये slitting. Slitting में remember दो टुकड़ा रहेगा. और ये lancing. Lancing में क्या होता है? ऐसा अभी यहाँ पे दो साइड से कट किया है और हल्का सा उसको नीचे दबाएंगे lancing में. These are used for locking. ये कर्लिंग है, यूजुअली डन फॉर द बकेट्स. इसके अंदर हम लोग वायर डालेंगे. देन दिस इज बेंडिंग ऑपरेशन. आपका फॉर्मिंग है. ये पार्टिंग ऑफ है, मतलब दो टुकड़ा सीधा. So this is kind of a shearing. This is V bending. This operation is for the plunging, drawing. This is planishing. Planishing is like a perforating only, but it is a large tool. इसमें tool size large रहता है and it is not used for piercing. It is generally used for making the strip flat. ये आपका प्रोग्रेसिव डाई है. दो स्टेशन है यहाँ पे. देयर आर टू स्टेशंस. ये पियर्सिंग है और ये ब्लैंकिंग है. तो यहाँ से स्ट्रिप आता है. ये जो स्टॉप है यहाँ पे अटकेगा, पियर्सिंग होएगा. देन ये जो पियर्स्ड होल है उसमें आपका ब्लैंकिंग का पंच जाएगा या पायलट जाएगा. So this is a typical progressive die. This is piercing. ये पायलट है और ये ब्लैंकिंग है. पायलट एक्ट्स एज अ गाइड. यहाँ से स्ट्रिप आ रहा है, पहला पियर्सिंग होएगा, फिर आगे जाएगा, लोकेट होएगा होल, फिर और आगे जाएगा और फिर ब्लैंकिंग. This is the construction of a simple tool which I will explain. Have a look here. दिस इज सेक्शनल एलिवेशन. ये स्पेसर है. स्पेसर का मतलब पैरेलल ब्लॉक. स्पेसर जो हम लोग डालते हैं, इट इज जस्ट टू इंक्रीज द हाइट ऑफ द टूल. बिकॉज यू रिमेंबर आई हैड टोल्ड शट हाइट. अगर शट हाइट आपका सपोज 200 है, 200, एंड इफ दिस आपका जो डाई का हाइट है, इफ इट इज से 190, then you cannot accommodate the tool. So in that case, you need to increase the height of the tool. So for that, you have to put spacer, yeah, parallel block. So this is what is your spacer or parallel block is. इसके ऊपर this is base plate, then this is your डाई ब्लॉक. डाई ब्लॉक में हम लोग बुश डालते हैं, जिसको कि डाई बुश बोलते हैं, और डाई बुश में आपका साइज आएगा, डाई साइज. सो दिस इज योर पंच साइज and this is your die size. So if it is blanking, then clearance is given on the punch. Punch is small. If it is piercing, then clearance is given on blanking on the die. So die size is bigger. Both the punch and die, they operate through the bush because ऊपर नीचे होते हैं. So if you directly cut this hole in this block, and since punch is hard and your die is also hard, it is quite obvious that your this die block as well as this stripper will wear out in 500 या 1000 pieces itself. So that's why we are using bush. So bush are hardened, and if the bushes are worn out, since it is hardened, if the bushes are worn out or if the bushes gets worn out, then the bushes can be replaced. This can be replaced. You don't have to change the entire stripper plate or entire die block. This is a dowel which is used for aligning stripper, die block, base plate. This is a guide pillar. Guide pillar is again hardened. So that's why it has to operate through guide bush. So this guide pillar aligns your bottom and top perfectly aligned. Okay, top half and bottom half. Bottom half is fixed and top half is moving. Again, you have dowel to align this and this. Okay, so this dowel aligns this and this dowel aligns this and this, and now this guide pillar aligns both, that is this and this. Okay, so that your entire tool is in perfect alignment. If the tool is slightly misaligned, and since the clearances are very less, 0.5%, that is zero point 0.1, so even if the tool is misaligned by 0.1, the punch will dash on the die and your punch and die will get spoiled. Then there is one more, that is how to hold this component. Now this and this, they are held together by this screw. Now this and this is held together by this screw. See, remember, see, look at this, how it is shown. There is a threading here, no threading here. So this will have a free hole, and again this counter bore will also have a free hole. Again, this and this is joined with the help of this screw. Now this is a die stop. What happens if suppose if the top half which is moving, in case suppose by some reason this gets loosened and if it falls down, then this is going to hit this surface and will get damaged. So that's why we put a die stop over here, and if this is falling down, it will hit the die stop. So die stop will get damaged. And die stop is a round piece of 20 mm dia. That's all. So die stop is used as the name suggests for stopping the die. Okay, so this will not hit directly over here. In order to have a better clarity, it is advisable that you should draw four views. And I told you what are the four views. These are the different strip layouts. Like suppose if you want, if your component is round, or if it is rectangle, or if it is of this shape, look at this shape. So you have to suggest a different layout. Now alternative arrangement for circle. If I want to improve the percentage utilization of the strip, then I can go for this design. So the percentage scrap will be reduced and utilization will be increased. Such a kind of design, say right angle triangle. If you take one after other, then obviously it is going to cost you lot. But if you take like this, then your scrap will reduce and your utilization will also improve. There is another example of how to use number of stations in progressive dies. Take example of this. This is a stator, and in that there are say 1, 2, 3, 4, 5, 6, and 7. 7 holes are there. So if you try to do this, and of course this is one outside. This is a blank, and there are 7 piercing punchings. Now if you try to do this at one station, so how many punches you will need? 6 holes, and this is one 7 holes के लिए 7 piercing punch plus वन ब्लैंक के लिए वन ब्लैंकिंग पंच, और ये ब्लैंकिंग पंच में से piercing पंच पास होंगे. सो द पंच विल बी वेरी क्लोज. दो प्लंज के बीच में जो गैप है वो बहुत पतला आएगा, एंड ड्यूरिंग वर्किंग ये जो वॉल है it may collapse and accident will happen. And corresponding to 7 punches there will be dies also in the fix half. वो डाई फिक्स करने के लिए आपको इंसर्ट्स लगेंगे, इंसर्ट्स के अंदर डाई कैविटी आएगा. So it will not be possible. So in that case, how we do? This has to be done in 4 stations. You cannot do it in 1 station. This die practically it will not work. तो हम लोग क्या करते हैं, पहला स्टेशन में खाली सेंटर का होल मार के लेते हैं. ओके, तो अभी पहला स्टेशन में क्या आएगा? ओनली 1 पंच एंड करस्पॉन्डिंग कैविटी. फिर दूसरा स्टेशन में क्या करेंगे हम लोग? ये 3 मारेंगे, 3 पंच करेंगे. दिस 3 पंचिंग, 1, 2 एंड 3. दिस इज ऑलरेडी डन. तो अभी दूसरा स्टेशन में क्या रहेगा? ये 3 पंच रहेंगे एंड करस्पॉन्डिंगली यू हैव डाई 3. Okay, so they are very well spaced. Then थर्ड स्टेशन में अभी ये 3 हो गया, सेंटर का भी हो गया, अभी ये रिमेनिंग 3. तो थर्ड स्टेशन में भी खाली 3 पंच रहेंगे और 3 नीचे डाई रहेंगे. एंड देन फोर्थ स्टेशन में क्या रहेगा? यू विल हैव अ पंच, ब्लैंकिंग पंच एंड ब्लैंकिंग डाई, ब्लैंकिंग पंच एंड ब्लैंकिंग डाई. हेलो सर. हाँ गुड. हाँ येतो, जरा लेक्चर मध्ये आहे, आता संपतोय. हाँ ओके. So this die will be minimum 4 station die. This will be minimum 4 station die. So like that you have to increase the number of stations so that the die will work इफेक्टिवली. सो दिस इज फॉर द सर्कलिप. ये सर्कलिप के लिए लेआउट बताया. ठीक है. फॉर द प्रोग्रेसिव डाई, as far as possible you have to, you should not make or you should not cut the die as a single piece. एक ही सिंगल पीस में नहीं कट करने का. You have to go for number of pieces. So आपका मशीनिंग भी इजी हो जाता है and it is good for maintenance also. Like this now here. So this is one piece, this is other piece, means I want this. और ये एक और एक पीस ऐसा डाल दिया. If you want to manufacture like this, then this is going to be very difficult. Similarly अभी ये देखो. Okay, so if you make it like this, आपका मशीनिंग इजी हो जाएगा. Now this corner you can mill easily with the help of the end mill on vertical milling machine. Similarly अभी इसको देखिए ये this. So we have used 1 2 3 4 5 6 inserts we have used here. Otherwise making this radius becomes difficult. So और एक एग्जांपल, why do we need inserts in the die block? अब ये वेरी कॉम्प्लिकेटेड शेप्स है. चाबी की हम लोग प्रेस के ऊपर कर रहे हैं. सो यहाँ पे अगेन वी हैव पुट इंसर्ट्स, वन इंसर्ट, सेकेंड, थर्ड, फोर्थ, और ये जो छोटा छोटा जो शेप है वो सब इंसर्ट के ऊपर दिए. सो बेटर एक्यूरेसी. Why do you need inserts in die block? Better accuracy, ease of manufacturing, then replacement and maintenance becomes easy, cost less costly and longer tool life. Only problem इसमें क्या होता है? The tool accuracy, alignment, that is the skill. अगर आप पूरा जो डाई है वो एक ही सॉलिड में कट करते हो तो ऑब्वियसली यू गेट अ गुड एक्यूरेसी. लेकिन सेम डाई इफ यू आर कटिंग इनटू नंबर ऑफ पीसेस, सो योर एक्यूरेसी इज चैलेंज्ड. ऐसा है. सारे का अलाइनमेंट, बिकॉज हर एक सब मान लो कि एक डाई में आप 6 इंसर्ट्स फिट कर रहे हैं और हर एक इंसर्ट के ऊपर आपको कुछ तो टॉलरेंस देना पड़ेगा, 0.01 0.02. सो क्यूमुलेटिव आपका जो एरर है वो 0.06 हो जाएगा. क्यूमुलेटिव एरर 60 माइक्रोन. हर एक में भी अपन 10 माइक्रोन का भी टॉलरेंस दिया तो 60 माइक्रोन का एरर हो जाता है क्यूमुलेटिव. वही अगर आप सॉलिड में कट करते हो पूरा तो यू कैन डू इट इन 10 और 20 माइक्रोन. सो एक्यूरेसी प्रॉब्लम हो जाता है. ओके, नाउ दीज आर द how to fix this insert. You can fix it from top, from this bottom, like this. This is a screw. These are the standard die sets which are available in the market. Market में available है standard die sets. Okay. These are the pillars. So हम लोग ये पूरा मार्केट में से लेके आते हैं और we concentrate only on punch and the die. These are the stops which I said that we use. स्प्रिंग लोडेड स्टॉप रहता है. मैन्युअली जब भी स्ट्रिप हम लोग डालते हैं तो ये स्टॉप है वो स्ट्रिप को अटक दे. इट स्टॉप्स द स्ट्रिप. और स्ट्रिप को आगे निकलने के लिए अगेन क्या करते हैं हम लोग, मैन्युअली उसको खींच लेते हैं सो दैट द स्ट्रिप मूव्स अहेड. सो देयर इज नो डाई डिजाइन. So if you have any doubt, you can definitely ask me. And if I get time, then definitely I will come to this sheet metal and I will teach you design. So next class may I will do unconventional machining, and then we will go for that lathe, milling, etc. etc. Now let me take the attendance. So DSC attendance. If you can tell me who is absent, that will be better. All are present here, or shall I call one by one? Or I will say Naik, Nila Naik, is she present? Absent. Okay, and what about this Rumao?
Yes,
Present?
sir. Present, present.
Okay, I'll take roll call. Shaunak?
Present,
Absent.
sir.
Present?
Oh,
Barbos?
Present, sir.
Valerav?
Present, sir.
Vedant?
present, sir.
Danny? Dimelo Sheldon?
Present, sir.
Elroy?
Present, sir.
Tyson? Saif?
Present, sir.
Mansi?
Present, sir.
Om?
Present, sir.
Sheldon Lopez?
Present, sir.
And then Shannon Lopez?
Present, sir.
Nila Naik is absent. Samiksha Naik?
Present, sir.
Dhruvi?
Present, sir.
Adrian?
Present, sir.
Chanel? Absent. Gerald?
Present, present, sir.
Channel is absent.
I Gerald present, sir.
Gerald present. Harsh is present. Archie?
Present, sir.
Yeah. Which class you have now? Which lecture? Which subject?
Thermodynamics.
Thermodynamics.
Okay. जरा पूछ ना. Okay. ठीक है. Thank you so much.
Thank you, sir.